Friends, in my previous videos, particularly last three videos, we have obtained the values of trigonometric ratios of 45 degree, 30 degree, 60 degree and 0 degree angles. In my previous videos, I have tried my best to explain about the values of trigonometric ratios of these angles by using animations. Today, we will find the values of trigonometric ratios of 90-degree angle. Many teachers have difficulty to explain the definitions of sin 90 degree equal to 1 and cos 90 degree equal to 0. To define sin 90 degree equal to 1 and cos 90 degree equal to 0, we will use three concepts. Students who are learning maths only for the exam purpose can skip this video. But if you want to learn maths seriously, you must watch. So let's start. To find the values of trigonometric ratios of angle 90 degree, we will define sin 90 degree is equal to 1 and cos 90 degree is equal to 0. Sometimes when a question is not resolved, accept it as a definition. At the high level, we will learn the definitions of these ratios based on the unit circle. At first, we will discuss three main points. First, when angle P is very close to 0 degree, angle R is very close to 90 degree. That is, angle P is approximately equal to 0 degree and angle R is approximately equal to 90 degree. Second, QR is nearly 0. That is, QR is approximately equal to 0. And third, PQ is almost the same as PR. That is, PQ is approximately equal to PR. Let us learn them all in details. Our first point, when angle P is very close to 0 degree, angle R is very close to 90 degree. In right triangle PQR, angle Q is equal to 90 degree. We know that angle P and angle R both are the acute angles. So we take angle P smaller than 90 degree. Then it is clear that angle R is smaller than 90 degree. For simplicity, let us suppose angle P is equal to 45 degree and angle R is equal to 45 degree. Here we have angle P is equal to angle R is equal to 45 degree. So PQ is equal to QR. Angle Q is equal to 90 degree. Therefore, PR is the hypotenuse. Look at the angular motion of hypotenuse PR. It is turned through a very small angle so that the angle P becomes smaller and smaller. We will see that angle P decreases from 45 degree to 0 degree. Here angle P is 45 degree and now we will observe how angle P decreases from 45 degree to 0 degree due to the angular motion of hypotenuse PR. Look at the angle P. It is 45 degree. Look at the angular motion of PR. Angle P is 40 degree. Look at the angular motion of PR. Angle P becomes smaller and smaller. It is 35 degree. Again, look at the angular motion of PR. Angle P becomes smaller and smaller. It is 30 degree. Look at the angular motion of PR. Angle P decreases from 45 degree to 25 degree. Look at the angular motion of PR. Angle P becomes smaller and smaller. Now angle P is 20 degree. Look at the angular motion of PR. Angle P is 15 degree. Look at the angular motion of PR. Angle P becomes smaller and smaller. It is now 10 degree. Look at the angular motion of PR. Angle P becomes smaller and smaller. It is now 5 degree. Look at the angular motion of PR. Angle P decreases from 5 degree to 0 degree, 5 degree, 4 degree, 3 degree, 2 degree, 1 degree, and it is 0 degree. Hence, when angle P is equal to 0 degree, the angle Q coincide with angle R and side PQ coincide with hypotenuse PR. We know that there is no possibility of 0 degree angle in right triangle. So we take P is not equal to 0, but P is very close to 0 degree. Now let us check what happens with angle R when angle P decreases from 45 degree to 0 degree. Again, look at the angular motion of the hypotenuse PR. Side PR turn through a very small angle so that angle R becomes larger and larger. As angle R becomes larger and larger, angle R increases from 45 degree to 90 degree. Angle R is 45 degree. Look at the angle R. Angle R is 50 degree. At the time, angle P is 40 degree. Look at the angular motion of PR. Angle R is 55 degree and angle P is 35 degree. Again, look at the angular motion of PR. Angle R is 60 degree and angle P is 30 degree. Again, look at the angular motion of PR. Angle R becomes larger and larger. Angle R is 65 degree and angle P is 25 degree. Again, see the animation. Angle R is 70 degree and angle P is 20. Hence, angle R becomes larger and larger. Angle R increases from 45 degree to 70 degree. And again, look at the angular motion of PR. Angle R is 75 degree and angle P is 15 degree. Angle R becomes larger and larger. Look at the angular motion of PR. Angle R is 80 degree and angle P is 10 degree. Look at the angular motion of PR. Angle R is 85 degree and angle P is 5 degree. Again, look at the angular motion of the hypotenuse PR. Angle R becomes larger and larger. Now see the animation. Angle R is 85 degree, 86, 87, 88, 89 and 90 degree. Hence, when R is equal to 90 degree, the angle R coincide with angle Q and side PQ coincide with hypotenuse PR. We know that there is no possibility of 90-degree angle in right triangle. So we take angle R is not equal to 90 degree, but angle R is very close to 90 degree. Hence, when angle P decreases from 45 degree to 0 degree, angle R increases from 45 degree to 90 degree. So when angle P is very close to 0 degree, angle R is very close to 90 degree. Our second point is, in right triangle PQR, QR is nearly 0. Suppose in right triangle PQR, angle Q is equal to 90 degree. So PR is the hypotenuse of triangle PQR. Suppose angle P is equal to 45 degree and angle R is equal to 45 degree. Hence angle P is equal to angle R is equal to 45 degree. So QR is equal to PQ. Let us take PQ equal to QR equal to 7 units. So by Pythagorean theorem, hypotenuse PR is approximately equal to 9.9 units. We have observed that angle P decreases from 45 degree to 0 degree and angle R increases from 45 degree to 90 degree. Look at the angular motion of the hypotenuse PR. As the measure of the angle P gets smaller and the measure of angle R gets larger, the length of the side QR decreases. We have QR is equal to 7 units. Now see how the length of the side QR decreases from 7 to 0 units. For this, let us divide side QR into 7 equal parts. So the length of each part is 1 unit. See in the figure. Now look at the angular motion of PR. Angle R becomes larger and larger. So the side QR decreases. See the animation. QR is equal to 7 unit. Now QR is equal to 6 unit. QR is equal to 5 unit. Angle R becomes larger and larger. QR is equal to 4 units. Angle R gets larger and larger. QR equal to 3 unit. QR is equal to 2 units. Angle R becomes larger and larger. QR is equal to 1 unit. And finally, QR is equal to 0. We know that there is no possibility of side QR equal to 0 in right triangle. So we take QR is not equal to 0 but QR is nearly 0, that is QR is approximately equal to 0. Our third point is PR is almost the same as PQ. In right triangle PQR, angle Q is equal to 90 degree, angle P is equal to 45 degree, and angle R is equal to 45 degree. We have observed that angle P decreases from 45 degree to 0 degree and angle R increases from 45 degree to 90 degree. Let PQ equal to 7, QR equal to 7 units, and hypotenuse PR is equal to 9.9 units. Look at the angular motion of the hypotenuse PR. We have PR is equal to 9.9 units. As the measure of the angle R gets larger, the length of the side PR decreases. We have hypotenuse PR is equal to 9.9 units. Now see how the length of the side PR decreases from 9.9 units to 7 units. Look at the angular motion of PR. Angle R gets larger and larger. Hypotenuse PR decreases. PR is equal to 9.9 units. PR is equal to 9 units. PR is equal to 8.5 units. PR is equal to 8 units. PR is equal to 7.5 units. PR is equal to 7.4 units. PR is equal to 7.3 units. PR is equal to 7.2 units. PR is equal to 7.1 units. And now PR is equal to PQ is equal to 7 units. But we know that hypotenuse PR is equal to side PQ is not possible in right triangle PQR. So we take PR is not equal to PQ but PR is almost the same as PQ. That is PR is approximately equal to PQ. Now we will find the values of trigonometric ratios for the angle of 90 degrees. In right triangle PQR, angle Q is equal to 90 degrees. If we take angle R is equal to 90 degrees, then angle P is equal to 0 degree. But we know that in any triangle, two angles of 90 degrees are not possible. So we consider angle R to be almost but not quite an angle of 90 degrees. That is, angle R is approximately equal to 90 degrees. We have observed that when angle R is very close to 90 degrees, QR is nearly 0 and PR is almost the same as PQ. That is, angle R is approximately equal to 90 degrees. Angle R is very close to 90 degrees can be written as angle R is approximately equal to 90 degrees. QR is approximately equal to 0. QR is nearly 0 can be written as QR is approximately equal to 0 and PR is approximately equal to PQ. PR is almost the same as PQ can be written as PR is approximately equal to PQ. To define sin 90 degree equal to 1 and cos 90 degrees is equal to 0, we will use these three concepts. By definition, sin R is equal to PQ upon PR. We have angle R is approximately equal to 90 degrees and PR is approximately equal to PQ. So we put angle R is equal to 90 degree and PR is equal to PQ. So we have sin 90 degrees is approximately equal to PQ upon PQ, but PQ upon PQ is equal to 1. So sin 90 degrees is approximately equal to 1. So we can define sin 90 degrees is equal to 1. When the question is not resolved, accept it as a definition. When we define something, there is no question of anything. So we write sin 90 degree is equal to 1. Now by definition, cos R is equal to QR upon PR. But we have R is approximately equal to 90 degrees and QR is equal to 0. So we put R is equal to 90 degree and QR is approximately equal to 0. So we have cos 90 degree is approximately equal to 0 upon PR, but 0 upon PR is equal to 0. So cos 90 degrees is equal to 0. So we can define cos 90 degrees is equal to 0. When the question is not resolved, accept it as a definition. When we define something, there is no question of anything. So we write cos 90 degrees is equal to 0. Now tan R is equal to sin R upon cos R. But we have angle R is approximately equal to 90 degrees. So we put R is equal to 90 degrees. So tan 90 degrees is equal to sin 90 degrees upon cos 90 degrees. But we know that sin 90 degrees is equal to 1 and cos 90 degrees is equal to 0. So we have tan 90 degrees is equal to 1 upon 0. But we know that division by 0 is undefined. So we can say that tan 90 degrees is undefined. We know that cosec theta is the reciprocal of sin theta. Cosec theta, sometimes we write CSC theta. So cosec 90 degrees is equal to 1 upon sin 90 degrees. But sin 90 degrees is equal to 1. We have defined. So we put sin 90 degrees is equal to 1 and 1 upon 1 is equal to 1. So cosec 90 degrees is equal to 1. We know that sec theta is the reciprocal of cos theta. So we write sec 90 degrees is equal to 1 upon cos 90 degrees. But cos 90 degrees is equal to 0. So we put cos 90 degrees is equal to 0. So sec 90 degrees is equal to 1 upon 0. And we know that division by 0 is undefined. So we write sec 90 degrees is undefined. And we know that cot 90 degrees is equal to cos 90 degrees upon sin 90 degrees, where cos 90 degrees is equal to 0 and sin 90 degrees is equal to 1. So we have cos 90 degrees is equal to 0 and sin 90 degrees equal to 1. So cot 90 degrees equal to 0 upon 1 is equal to 0. Division by 0 is undefined. So tan 90 degrees is equal to undefined, and similarly sec 90 degrees equal to 1 upon 0. Division by 0 is undefined, so we write undefined. Usually the symbol infinity is used for undefined terms. Infinity is not a number. In the next video, I will illustrate the use of the values of trigonometric ratios through some examples. Friends, the best way to learn trigonometry from Magic Sir is to watch the video till the end. Then mute the audio and enjoy the video with PowerPoint animations again. Now look at the table and enjoy the animations.